Okay, now we're going to look at functions. But before we talk about functions, let's consider relations. Relation occurs when you have two objects that are related to each other. And this could be represented in several ways. One way is as a set of points. So for example, we could have this idea that 1 and 6 are related, 2 and 7, and 3 and 8. Maybe think about that for a little bit. How are they related? Well, if you know that x is 1, if you know that this first value is 1, the second value is found by adding a 5. And that occurs for each of these ordered pairs. So we have some sort of relationship occurring. Now we call that first value, this right here, is our input, because I said you put in a 1, and we call this 6 our output. And both these have some other names here. We say the domain, and we also have the range. Now, for a relation to be a function, each input is associated with exactly one output. So for example, we can consider like the states in the United States and their capitals. And we'll just select a few to look at. So let's say we have California. We know that that has a capital of Sacramento. We have Oregon, which has Salem, and Washington, which has Olympia. Now previously we said we could talk about these relations as ordered pairs, but we could also do something called a mapping. And this is where we're representing our inputs in one circle and our outputs here. And to show where they're going, we say California goes to Sacramento, Oregon goes to Salem, and Washington goes to Olympia. This is a mapping. In particular, it's a mapping of a function, because you know that for each of these individual states, there is exactly one capital corresponding to it. So we say, like, when you put in California, you know exactly what you're going to get out, which is Sacramento. Now, if we want to consider something that is not a function, we can look at this example. Let's look at the age of students and the name of students. So if I put in an age of, let's say, 20, 26, and 18, and I have a few students, say Greg, James, Andrew, and Matthew, and I know that Greg is 20, Andrew's 20, James is 26, Matthew's 18. This is not a function because when I put in the age of 20, it corresponds to two outputs, which makes it not a function. So you put in a 20, sometimes you're going to get Greg, sometimes you're going to get Andrew. It's not a function. Now we have another word for our input. An input is an independent variable. While the output is a dependent variable because it depends on what you put in for your input. So we have that it's a dependent variable. Often for our inputs we will use the letter X and we will use Y for our outputs. And we name our functions often with the letter F. So let's look at this function f. So this is our name. And I'm going to describe what it does. It's a function that associates a month with a number of days in that month. So we could even write this f of x, that's what this means here, and just telling you what you're going to be putting in. So if we think about what we could put into it, we have our inputs, or our possible domain, is going to be all the months of the year. So we have January, February, March, April, May, June, July, August, September, October, November, and December. So I just wrote the domain as a set of all of the months. And then if we think about what our output could be, our output, or our range, will be all the different possible number of days that are in these months, which would be, there's 28, let's look at a regular year, no leap years here, 30 or 31. So we'll say f of x, you plug in something, that gets you your y. So that's our input and our output. So for example, if I put in January, I would get 31 out. That's our notation. If I put in February, I would get 28 out. So that was a little bit of our notation. We can also consider graphs of functions. So let's consider this set of ordered pairs, 1, 1, 2, 4, 0, 0, negative 1, 1, and negative 2, 4. If you look this closely, the relationship you can see is that when you plug in an x value, you get the square of that x value. So this is just a few points to get us an idea of what the graph of this function is. This function is f of x equals x squared, where we could plug in any value that we want. So we're going to have an infinite number of points. So let's see, we're going to have 1, 1, 2, 4, 0, 0, negative 1, 1, negative 2, 4. Now that's just a set of points that I identified here, but if I want to list all the possible values that satisfy this function, I would have this continuous line here. It's going to go up forever because I'm going to plug in an infinite number of x's, positive values and negative values, which gets me this graph. Now, this is a function because we know that for every x value, there is exactly one y value. And then we can see graphically that this is true as well by something called the vertical line test. If you think about vertical lines, they go through the x-axis. So if I draw a vertical line, you can see that for this x value, it corresponds to one y value. And we can continue drawing this. Again, you can see that for every x value, it corresponds to exactly one y value. So it passes the vertical line test. So it is a function if each vertical line hits graph one time. Now let's consider this relation, x equals y squared. If I try and put some points that satisfy this, let's see. It's kind of easier to plug in some y values since it's squaring our y. So I'll put in 2, negative 2, 0. That'll give me 4, 4, 0. Let's see what this is. When I plug in a 4, the only thing that could get me would be a 2, or wait, it could get a negative 2. I'm also at 0, 0. Let's try a little bit more here. If I were to square 1, I get a 1. If I square negative 1, I get a 1. So I know that 1 corresponds to 1 and negative 1 here. So I'm getting this picture. It looks kind of like one before, but it's tilted to the right. Now if you think about this and look at our table, you see that for this x value of 4, we correspond to two different y values. So we know that this is not a function. And graphically, if we do our vertical line test, each of these lines, again, corresponds to one x value. But you can see we're touching our graph with each of these lines twice. So it fails the vertical line test. So graphically, you can see that it's not a function. So here, let's have you guys try this. Is this relation a function? Why or why not?